Here's problem 3720. The light reflected from a soap bubble, index of refraction 1.4, appears red, wavelength 640 nanometers at its center. What is the minimum thickness in nanometers? Now the fact that this appears red means that that color is being enhanced, that is being constructively interfered. So that color is being constructively interfered. The other wavelengths are being, at least in some point, they're being phased out, so to speak. So we're going to have constructive interference due to or with one phase reversal on this bubble. Because the way it's going to look is we're going to have a bubble like this, and our light's going to come from air to the bubble, which is index 1.4, back to air. So the light coming in might look something like this. It's coming in, I need to use red. It's coming in, refracting towards the normal here, reflecting as we go from a higher index to a lower index, like this, and coming out, and that light is being preferentially constructively interfered. But we are going to have one phase reversal at this first reflection as we go from a lower index to a higher index, and no phase reversal at the second interface because we're going from a higher index to a lower index. So there's one phase reversal, which means in order to get constructive interference, we want the path difference within the medium to be equal to half a wavelength. And the wavelength within the medium is going to equal the wavelength outside in the air divided by the index of refraction. So that's going to be 640 nanometers divided by 1.4, and that is equal to 457 nanometers. So that is the wavelength that we're dealing with inside the bubble. Alright, so we want that the thickness of this bubble, we want the path length will be twice that thickness. So we have the twice the thickness will be equal to m plus 1/2 times the wavelength within the bubble medium. We want to solve this for the thickness. So the thickness will equal m plus 1/2 times the wavelength within the bubble medium divided by 2. And we're going to choose m equal to 0. We'll just find the minimum thickness because that's what was asked for. So we'll choose m equal to 0. And what we have is we're going to have 1/2 times 457 divided by 2. So that's 457 divided by 4 altogether, 114.3 nanometers. So the thickness of this film, at least the minimum thickness of the soap bubble, is 114.3 nanometers.